Unit 6, Quadrilaterals and Other Polygons, Properties of Parallelograms, Lesson 6.3. That's what we're doing today. Let's learn something new. Lesson 6.3, Properties of Parallelograms, Polygons in the coordinate plane. We are going to include those with Desmos activities, and I'm sure I'll have a recording dealing with that in the future. Show that the consecutive angles of a parallelogram are supplementary and opposite angles are congruent. We'll do that in Desmos. Show that opposite sides of a parallelogram are congruent. We'll do that in Desmos. Show that diagonals of a parallelogram bisect each other. We'll do that too. Definition of a parallelogram. It's a quadrilateral in which both pairs of opposite sides are parallel. And there's a diagram for it. Other important properties of parallelograms. So that was definition. These are properties. Opposite sides are congruent. Opposite angles are congruent. Consecutive angles are supplementary, which is difficult to show on a diagram, so I don't have one there for you. But diagonals bisect each other. There you go. All these different properties. So if we know a quadrilateral is a parallelogram, then we know all these properties, and yeah, we're going to write equations and solve. Let's do it. Examples. We are given that each quadrilateral is a parallelogram. We need to find the missing measures. So we're going to use all the properties we just discussed to do this. Length of segment AD has got to be 8. It's opposite segment BC. And length of segment DC has got to be 15. It's opposite segment AB. Let's see, the easiest angle to do is B because it's opposite angle D, which is 68. And the other two are going to be supplementary to that 68, which is 112. So measure of angle A and measure of angle C are both 112. Number 2, length of segment JK is 21. Length of segment KL is 29. Easiest angle is angle J, 127. Let's do a little subtracting from 180. And the other two angles are 53 degrees. Number 3. Let's see. Length of segment UT is 27. Length of segment ST is 18. Length of segment VS. Diagonals bisect each other, so that must be 7. And they tell us length of segment RT is 30. And we want length of segment VT, which has got to be half of that. And half of that is 15. So length of segment VT is 15. Now we have a bunch of angles and a bunch of 3-letter names. We know alternate interior angles are congruent, so that's going to help us find some. So that angle's also 71 degrees. That's angle ECD. And this angle's 21 degrees. And let's see, we know measure of angle FED is 134. So if we subtract the 71, we're going to get 63. And that's going to be that angle there as well as that angle there. 180 minus that 134 is going to give us 46. That's the measure of angle CDE. But if we get rid of the 21, then we'll get that last angle that we need. Measure of angle DFE is 25. Parallelograms again. We know it's a parallelogram. Solve for x. Those are opposite sides. They must be equal to each other. So set them equal. Move the smallest x. So we're subtracting 5x on both sides. We get 4x minus 25 equals 7. Add 25 to both sides. 4x equals 32. Divide both sides by 4, x is 8, and we're done with that one. This one, we want to find the length of segment YZ. Opposite sides are going to be congruent, but we're not going to stop once we get our x. So set them equal to each other. So 11x plus 1 equals 19x minus 31. Move the smaller x, which is 11. Subtract 11x on both sides. We get 1 equals 8x minus 31. Add 31 to both sides. 32 is equal to 8x. When you divide by 8, x is 4. We're not totally done though. We need to substitute in because we need to find the length of segment YZ. So the expression for that is 19x minus 31. In place of x, we put 4 because we just found out x was 4, and calculate, and length of segment YZ is 45. Number 7. If TV, length of segment TV, that whole diagonal 74, and length of segment WV, just this part, is a 4x plus 1, then TV is going to be double the length of segment WV because diagonals bisect each other. TV is twice length of segment WV. I just told you that. Substitute everything in. We will need to distribute. So that 2 multiplies to the 4x plus the 2 multiplies to the 2. So 74 equals 8x plus 2. Subtract 2 on both sides. 72 is 8x. Divide both sides by 8 and x is 9. Let's look at the next one. If length of segment NS is 2x plus 7, that's that part of the diagonal, and length of segment SQ is 5x minus 23, so the diagonals bisect each other, so those two segments should be equal. So let's set them equal to each other. 2x plus 7 equals 5x minus 23. Move the smallest x. Subtract 2x on both sides. So we get 7 equals 3x minus 23. Add 23 to both sides. 30 equals 3x. Divide both sides by 3. X is 10, but we're not done. We need the length of segment NQ, and NQ is the entire thing. So there's more than one way we can do this. We can substitute into one of the expressions and double it. We can add the two expressions together, get an algebraic expression for that and substitute in and get our answers. So there's more than one way you could attack this. NQ is twice NS, and we have an expression for the length of segment NS. So this is the way I attacked it. Distribute. So length of segment NQ is 4x plus 14, and we know what x is. So in place of x, we're going to put 10. And when you calculate, you get 54. Number 9, we need to find the measure of angle B, but we have expressions for A and C. It says that it is a parallelogram, so those two must be equal to each other. So 6x minus 15 equals 4x plus 11. Subtract the smaller x on both sides, so subtract 4x on both sides. 2x minus 15 equals 11. Add 15 to both sides. 2x equals 26. Divide both sides by 2. X is 13. So we have that part. We just need to find measure of angle B. So let's plug this into the expression for the measure of angle A. We have 6x minus 15. Put 13 in place of x. Measure of angle A is 63, and we can subtract that from 180 to get the measure of angle B and D because they are the same, and that's 117 degrees. Let's see, we want measure of angle R, and we are given consecutive angles. They are supplementary. So we're ultimately going for that, but consecutive angles are supplementary, which of course means they add to 180 degrees. Everything from day one's fair game. All right, so add those two expressions together. 3x plus 5 plus 8x minus 12 equals 180. Combine like terms. 11x minus 2 equals 180. Add 7 to both sides. 11x equals 187. When you divide by 11, x is 17. But we want the measure of angle r. So I'm going to plug it into the expression for the measure of angle P, because those are opposite angles and those are going to be congruent. So 3x plus 5. Let's put our 17 in place of x, and we get the measure of angle R is 56 degrees. Here's another one. If PQRS is a parallelogram, find the values of x and y. So the x's are opposite sides. They've got to be congruent, and the expressions with the y's are consecutive angles, so those would be supplementary. Let's do opposite sides congruent first. So 13x plus 15 equals 19x minus 9. Subtract the smaller x on both sides, so subtract 13x on both sides. You get 15 equals 6x minus 9. Add 9 to both sides. 24 equals 6x. So when you divide both sides by 6, x is 4. We have part of it. Now the other two are supplementary, so they're going to add to 180 degrees. So 10y minus 37 plus 4y plus 7 equals 180. Combine like terms. We get 14y minus 30 equals 180 degrees. Add 30 to both sides. 14y equals 210. Divide both sides by 14. Y is 15. And we have both x and y. Number 12, opposite angles. But ultimately, we want to find the measure of angle C. But we have expressions for measure of angle B and measure of angle D, which are opposite each other. And opposite angles are going to be congruent if it's a parallelogram, which they told us it was. So 8x minus 19 equals 5x plus 38. Subtract your smaller x on both sides. So subtract 5x on both sides. You get 3x minus 19 equals 38. Add 19 to both sides. You get 3x equals 57. Divide both sides by 3. X is 19. Consecutive angles are supplementary, but we don't know what one of the angles is yet. We need to plug it in. So I'm going to plug it into angle B. Could have done D. Doesn't matter. They're going to be the same anyways. So the expression for the measure of angle B is 5x plus 38. And we're going to plug in our 19 that we found for x. So measure of angle B is 133 degrees. So we need to subtract that from 180 so we can get the measure of angle C. Measure of angle C is 47 degrees. Diagonals of parallelograms. Example, if a quadrilateral is a parallelogram, then the diagonals bisect each other. Okay, let's see. So that's 10, that's the opposite side. That's 15, that's an opposite side. CE must be 7 because diagonals bisect each other. And length of segment GD is, let's see, half of 22 because they told us length of segment FD is 22. So half of that is 11. Diagonals again. If length of segment AC is 8x minus 14, that's an entire diagonal. And length of segment EC is 2x plus 11. That would be half of it. So length of segment EC, if we double it, we should get the length of segment AC, the entire diagonal. So that's the whole thing, and that is just half of it. Diagonals bisect each other, so length of segment AC is twice EC. Let's plug it in. You're going to have to distribute. So we need to multiply the 2 on the outside of the parentheses by the 2x and by the plus 11. So 8x minus 14 equals 4x plus 22. Subtract your smaller x on both sides, so subtract the 4x on both sides. 4x minus 14 equals 22. Add 14 to both sides. 4x is 36. X is 9. We have now finished lesson 6.3, Properties of Parallelograms. Hope you learned something new.